Get up to speed with the EZPath S from Bridgeport Machines. Turning productivity has never been easier or faster to achieve than with
Okay, so setting up tools in the EZPath software, you're going to go into the tool library and you're going to press the plus sign. And that's going to bring up a menu, and you have all these different types of tools that you can set up. Something important to notice is that there's a plus sign on all of these. Every single tool in this menu has a plus sign, and that plus sign is the control point. So every time when you're using a tool and your offset is active, that is the actual point that you're moving around. So for example, when we hit number 5 to set up a C insert, it's right there. That's where it's going to be. It's tangent to the radius of the tool, right? So now if we're going to set this tool up, so it's going to be tool number 1. It's an inch tool. Now the distance to X and Z touch off, that's going to be 0. That is not your tool offset. There's only very specific cases where you would want to put numbers in here, but 99 times out of 100, that's going to be 0. Now setting up a C insert, it's going to have a 5-degree angle, and it's an 80-degree rhombus, and it's going to have a 15 thousandths tip radius. And that's it. That's how you set up a tool. It's very simple. Again, distance to touch off is not your offset. That is a different thing, and I'll demonstrate that right now. If you hit F1, it will show you the tool. You can see that red plus sign, and that red plus sign is the control point. Now if I go back into this tool, if I hit the asterisk and then I go to distance to touch off and I hit, let's go 1/4 of an inch in X. Now when I view that tool again, you'll see that this changed by 1/4 of an inch. The touch off point is now 1/4 of an inch behind the X. The tool is 250 thousandths forward of the touch off. So that is not your tool offset. That is an offset of the touch off point. And again, there's only very limited types of things that you'd ever need to put numbers in there. So that's always, pretty much always going to be 0. Okay, so now if we wanted to set up another tool, we're going to set up a V insert, like a VCGX insert tool. So we're going to hit plus sign. It's going to be number 5. This is going to be tool number 2. Distance to etch is both 0. Angle 1 is 5, and it's a 35-degree insert, and a tip radius of 15 thousandths. So now if we view that tool, that's a V insert. And again, notice that it has that red plus sign. So it's very important to know that that red plus sign is your touch off point, and it's tangent to the radius of the tip of the tool. Okay, so something very important when I was pointing out in the tool library, the control point. If you look at this tool, let me just modify this so that it actually zooms in to where we can see it. Okay, so this is a CCGX 80-degree diamond, and it's in an impossibly small holder, but that's the only way that you can get it to zoom in far enough where you can see this detail. So it's very important that this black dot right here, that is the control point that Fusion is going to use to program this tool. So if you go to setup, under compensation, tip tangent, if you hover over that menu, you'll see that there's 4 options, and those 4 options will program very different tool paths to make the same tool make the same cut. So the way EZPath software works is it's this tip tangent. You must have your tools set up in Fusion 360 as tip tangent. And that's the only way that you'll get a toolpath out of Fusion that will actually cut the part that you're looking to cut. If you overlook this, you're going to be scratching your head trying to figure out why you're not getting the desired results. So now I can demonstrate this by, if you take a look at this illustration, the black dot is tangent to these 2 edges. If you change this to tip center, now the control point is the center of the radius on the tool. So that's not going to be what you want. So anytime you're going to use a CAD program, you have to make sure that you set your tools up properly, not only in the EZPath software, but in your CAM software, so that it outputs the correct path for your machine. Now I can accentuate this by going back to the insert and putting a really big radius on it. So I put a 1/16 radius on it. You'll see that these black lines are right tangent to the radius of the tool. So when you touch your tool off in X and your part comes up and touches this up furthest most edge, that's a 0. And then when you bring your tool up in Z and it touches this furthest most point, that's going to be your Z. So make sure, if you're using Fusion 360, Mastercam, whatever you're using, make sure you go into the tool setup and you set the compensation to tip tangent. It's very important. Now, another thing you really want to be mindful of is that you make sure that the radius that you programmed the tool is the correct for the actual tool, because the way that it's going to control the toolpath is based upon that radius. So if you have any chamfers or any radiuses on your part, it's going to need to know the radius of the tool. This way it can properly compensate for that radius as it makes it around that curve. And it's very important also in the EZPath software to make sure that you put the tip radius correctly, that you set that correctly, because anything that you program, if you program paths in the EZPath control, it's going to take that tip radius into account when you then do a roughing operation or a profile operation. It's going to use that tip radius to know where it needs to place the tool to go around a curved piece of geometry or a chamfer or anything that has any sort of shape to it. Okay, so if you look at the machine, it will look something like this. Now what we need to do, we need to be able to work efficiently, is to set our work shift and our tool offsets. So what we're looking at is the boundary of the machine in red, the sample workpiece, our machine home position in the bottom right corner, and what we'd like to set as our work coordinate at the face of our part. It would seem logical to put a tool in the holder or the turret and touch it off to the workpiece and set our tool offsets. The machine would then know exactly where to position itself to get the tool to the desired position. However, then if we put a workpiece in the machine that has a different length, we must go back and reset all of our tool offsets to the new workpiece length. So this is the reason why we have the work shift function. So the way most people set these machines up is using the standard tool method. So the standard tool method uses one standard tool to set your work coordinate. That tool would then have a tool offset of 0 in both X and Z, because that tool is what the work coordinate is based off of. The tool offsets are offsets from the work coordinate location, not the machine home position. Since tool 1 is the gauge of that the work coordinate is based on, the two tool offsets would follow the work coordinate when it's changed using the work shift. It's important to note that the x-axis 0 is always the spindle center line. The only time you really need to set a diameter value in the work shift prompt is when you are setting your standard tool. To set your standard tool, first you need to determine what tool is a tool that you'll commonly use. For me, it's a C-style insert tool, as that's the most common tool I use. Using this tool as tool number 1, place a piece of scrap material on the spindle and turn the face of the part clean with that tool. Only back the tool off in the x-axis, press 7 for work shift and enter 0 in only the z-axis box. Then you'll use the tool to turn a clean diameter on the piece of scrap, and only back the tool off in Z, press 7 and enter only the measured diameter into the diameter box. Tool number 1 is now set as your master tool and your work coordinate is set. The X0 point is the center line of the spindle and the Z0 point is the face of your piece of scrap. Now load tool number 2 into the machine and press 1 to change tools and offsets to tool number 2 in the EZPath software. Once tool number 2 is in the machine, it's going to use offset number 2. Use a gauge block or a gauge pin to touch off the tool to the Z face of the part. Once you have it in position, press F2 to enter the tool offsets page. Press the Z button on the keypad and enter the value of the gauge block. Then use tool number 2 to turn a clean diameter on the piece of scrap. Back the tool off in only the Z axis. Press F2 to enter the tool offsets page and press X on the keypad. Enter the measured diameter into this X-axis actual diameter box. Now tool 1's offset is 0 and equal to the work coordinate, and tool 2's offset is the difference in dimension between the control point of tool number 1 and tool number 2. Now when you work on a workpiece that has a longer Z length, you would use tool number 1 to touch off on only the Z face of the new workpiece, or the piece of stock that you're working on. With the tool in position, you would press 7 to enter work shift, and enter only the Z-axis value of 0 or the dimension of your gauge pin or block to set the new z-axis work coordinate. Once you do that, tool 2's offset is offset from the work coordinate system, so all other tool offsets will change in z according to the work shift. And that's pretty much it. Once you have your tools set up in the tool library correctly, making sure that the tip radius matches the physical tool, and you have your tools correctly set up in your CAD and CAM software with the correct compensation of tip radius, when you output toolpaths from a program like Fusion 360, they should work correctly and have accurate results on the machine. I hope this was informative. I'll be making more videos on this machine and the EZPath software coming soon.